AI reasoning has just taken a huge leap forward, and the open source community is shaking things up. A new model, trained on only 14% of the data used by its competitors, is outperforming industry giants. Meanwhile, another model is redefining logical problem solving by using hidden loops to think in a more advanced way. If you assumed cutting-edge AI was only for billion-dollar labs, think again. These new models are proving that smart design can beat brute force computing. One of the most exciting developments is OpenThinker 32B, created by the Open Thoughts team. This model is making waves because it's fine-tuned from Alibaba's Qwen 2.53 Tob Instruct and comes loaded with powerful capabilities. OpenThinker 32B is built with 32.8 billion parameters and supports a 16,000 token context window, making it a powerful AI model. But what really makes it stand out is its unique training approach. The model was trained on the OpenThoughts 114K dataset, exactly 114,000 carefully curated examples. This isn't just random data. Each example includes detailed metadata, such as ground truth solutions, domain-specific guidance, and coding test cases. To ensure accuracy, the team used a custom curator framework to verify code solutions. For math-related tasks, an AI-based judge was used to validate proofs, ensuring the model learns to reason effectively through complex problems. Training took place over 3 epochs, 3 full passes through the dataset, using the Llama Factory framework. They fine-tuned the model with a learning rate of 1 × 10 to the power of -5 and a cosine learning rate scheduler, which gradually adjusts how fast the model learns over time. As for the computing setup, the team used AWS SageMaker, running on 4 nodes, each with 8 H100 GPUs. Despite the massive scale, they completed training in just 90 hours. Additionally, they experimented with an unverified dataset of 137,000 samples, which they ran on Italy's infrastructure. The Leonardo supercomputer was also put to the test, burning through 11,520 A100 GPU hours in just 30 hours. The results? Even the unverified model performed decently, but the fully verified version still outshined it in raw performance. So how does OpenThinker 32B compare to other open source reasoning models? Pretty impressively, on the Math 500 benchmark, it scored a massive 90.6%, surpassing even some big-name proprietary models. For general problem solving, it earned a 61.6 on the GPQA Diamond benchmark. When it comes to coding, OpenThinker 32B put up a solid 68.9 on the LCBV2 benchmark, though it was slightly outperformed by DeepSeek's similar-sized model, which scored 71.2. But since OpenThinker 32B is open source, developers can fine-tune it further, meaning that score could improve quickly. And that's the real game changer here. While major AI labs like OpenAI and Anthropic keep their models, data, and training methods under wraps, OpenThinker 32B is fully open source. That means anyone can download it, analyze the code, check the data, and even replicate or improve the training process. Despite being trained on just 14% of the data used by competitors like DeepSeek, it's already matching or outperforming some high-profile closed models. This proves that smarter design can beat sheer data size, making OpenThinker 32B a huge leap forward for open source AI. That's right, while DeepSeek trained on a massive 800,000 examples, OpenThinker 32B achieved similar results with just 114,000 examples. A clear win for data efficiency. Now let's compare OpenThinker 32B directly to DeepSeek R1, an open source model developed by a Chinese team. However, unlike OpenThinker, DeepSeek R1 hasn't made its training data publicly available. In terms of performance, OpenThinker 32B edges out DeepSeek R1 on key benchmarks. Math 500 OpenThinker scores 90.6%, slightly beating DeepSeek R1's 89.4%. GPQA Diamond, general problem solving, OpenThinker leads with 61.6%, compared to DeepSeek R1's 57.6%. However, DeepSeek R1 has the upper hand in coding tasks and specific math benchmarks like AIME, where OpenThinker falls just short of the top spot. Overall, it's a very close race, but the real takeaway is that OpenThinker 32B is competing at the highest level, sometimes even surpassing DeepSeek R1, despite using significantly less training data. This success is a big win for the open source community. The OpenThinker team has hinted at future upgrades, which could include expanding the context window or making architectural improvements to enhance performance even further. For those who don't have the hardware to run a massive 32B parameter model, there's also a lighter 7B version. While it's not as powerful, it's a great option for experimentation on budget-friendly GPUs. But OpenThinker isn't the only groundbreaking model in the AI reasoning space. Another exciting player is Huggin 35B, which takes a different approach to AI reasoning while packing even more parameters. Developed by an international team from institutions like the Ellis Institute, Tübingen, and the Max Planck Institute for Intelligent Systems, Huggin 35B aims to push AI reasoning to the next level with its unique training strategy. Huggin 35B was developed by a diverse team from Tübingen AI Center, the University of Maryland at College Park, and Lawrence Livermore National Laboratory. This mix of institutions highlights the model's broad goals and serious research backing. One of Huggin 35B's standout features is its unique approach to AI reasoning, called latent reasoning. Unlike traditional chain of thought (COT) methods, which explicitly lay out each intermediate reasoning step in text, Huggin 35B keeps most of its processing internal. This means the model doesn't need to generate and store step-by-step tokens in its output. Instead, it continuously refines its internal states until it reaches a confident final answer. This is especially useful for handling complex or large queries without quickly maxing out the context window. At its core, Huggin 35B relies on a recurrent depth mechanism, essentially a way to iteratively process information more efficiently before delivering a response. Huggin 35B takes a different approach to reasoning by looping through its hidden state multiple times during inference. Instead of generating a step-by-step breakdown like traditional chain of thought (COT) methods, it refines its internal representation in multiple passes, making small adjustments along the way. And think of it like someone solving a math problem on the back of an envelope. They go over their notes, tweak details, and correct mistakes without having to write out every single step explicitly. This method makes Huggin 35B especially effective for tasks that require deep reasoning, such as complex proofs or multi-step code generation. One major advantage of this approach is memory efficiency. Traditional COT models generate lots of intermediate reasoning tokens, which can quickly fill up the context window. Huggin 35B avoids this issue by iteratively refining its internal state, almost like making mini updates to a mental scratchpad instead of needing extra tokens or a bigger context buffer. Under the hood, Huggin 35B is still a transformer-based model, but its ability to loop through reasoning steps internally makes it more efficient and scalable for complex problem solving. Huggin 35B takes a unique approach by incorporating a looped processing unit that allows the model to perform additional rounds of computation on its hidden states. Instead of increasing its parameter count, this looping mechanism deepens logical processing at inference time, adjusting its reasoning complexity dynamically by carefully tuning the number of iterations. Huggin 35B can either increase computational depth for complex problems or speed up processing for simpler tasks by using fewer loops. The model was trained on a massive 800 billion tokens covering a mix of general text, code, and mathematical reasoning, ensuring versatility across different domains. Unlike models that rely on memorization or single-shot reasoning, Huggin 35B was designed to think through problems internally, refining its solutions across multiple passes. In benchmarking, Huggin 35B excelled in reasoning-heavy tasks like ARC, AI Reasoning Challenge based on standardized test questions, GSM-8K, a widely used math reasoning benchmark. Despite having only 3.5 billion parameters, it outperformed larger models like Pythia 6.9 billion and Pythia 12 billion, proving the efficiency of its recurrent depth architecture. One of Huggin 35B's standout features is its ability to adapt processing time based on task difficulty. For complex problems, it runs more iterative passes, refining its solution. For simpler tasks, it reduces loops, speeding up inference and conserving compute power. This flexibility makes Huggin 35B highly efficient for real-world applications, where hardware constraints and speed requirements vary. Thanks for watching. See you in the next one.